Let's talk about finding the area of regular polygons. So the area formula for any regular polygon is 1/2 times A, which is the apothem, times P, which is the perimeter. So the apothem and the perimeter. You're probably aware what the perimeter is. It's just all the side lengths added up. But the apothem is a little bit different. If you take, say for this pentagon right here, and you draw a dot right in the center of the shape, and you extend a line from the dot to the center of one of the sides to make a 90-degree angle with that side, that is the apothem. Now the apothem is not from the center to a vertex. That's different. And also, for a regular polygon, well, a regular polygon in the first place is any shape that has equal length sides and equal measure angles. So think about an equilateral triangle, a square, a pentagon, and so on and so forth. Now I just want to say one thing. For a triangle and for a square, your area formulas are going to be different than this. You can still use this, but it's a little bit more difficult to use this formula. So for a triangle, just remember area is equal to 1/2 times your base times your height. And for a quadrilateral, which basically is just a square, area is length times width, but remember all the sides are the same length. So we can say side times side, which just reduces to side squared. So now that we've covered that, let's go ahead and find the area of a pentagon whose side length is 4 inches. So the first thing I'm going to do is draw a dot at the center of the circle, at the center of the pentagon, extend a line straight down to the center of one of the sides, and then from here, let's go ahead and draw a triangle. So from the center to each of the nearest vertexes. Now I want to figure out what the angle of this triangle is right here, and you'll see why in a second. So to figure that out, let's take 360 degrees and divide it by how many sides the shape has. In this case, it's by 5. So if you put this in your calculator, 360 divided by 5 is 72. So right here, this angle is going to be 72 degrees. Now here's a little trick. Actually, let me draw this 90 degrees so that we're certain it is. If that is 72 degrees, this whole angle, and it has been split in half, then this angle right here should be 36 because we're splitting 72 degrees in half. So look at this. We got the apothem, and then now we know that since one of these sides, or all of these sides, is 4 inches, a side split in half is going to be 2 inches. So what we're left with now is a triangle, and we know an angle of the triangle, we know the length that's opposite of the angle, and we're looking for the side length that is adjacent to that angle. So if you think back to trigonometry, we can use tangent. So tangent of 36 equals our opposite, so 2 inches, over our adjacent, which is our apothem. So to solve for our apothem, we can just do 2 inches divided by tangent of 36 degrees. If you put that in your calculator, you're going to get 2.75 inches. Okay, now let's go ahead and put that into our area formula. Area equals 1/2 times the apothem, so 2.75 inches, times the perimeter. So since one side length is 4 inches, and there are 5 equal side lengths, our perimeter is 20 inches. So if you plug this in, you're going to get 27.5 square inches. Okay, let's do another example. What if you have a hexagon? So, give it the same treatment, dot at the center. We're going to draw our apothem down. You can draw that 90 degrees if you want to. And then let's create a triangle. Now let's figure out what this angle is. So 360 degrees divided by 6, that's going to be 60 degrees. So this big angle right here, 60. Now if we give it the same treatment as last time, only one of these triangles has a angle of 30 degrees. And then this side, since we split 12 feet in half, this part's going to be 6 feet. Now if you remember your rules for triangles, this is going to be a 30, 60, 90 triangle. So actually, let me go ahead and go on that tangent real quick. So for a 30, 60, 90 triangle, if you know the shortest side, x, which is opposite of the 30-degree angle, your hypotenuse, which is opposite of your 90 degrees, is going to be 2 times x. And then the middle side is going to be x times the square root of 3. So then, if we know that, then we know that our apothem is going to be 6 times root 3 feet, just by following this rule right here. So let's go ahead and find the area now. Area 1/2 times the apothem, which we figured out is 6 times the square root of 3 feet, times our perimeter. So if one side is 12 feet and we got 6 sides, our perimeter is going to be 72 feet. Now you don't even need a calculator for this. 1/2 times 6, that's going to be 3. So we have 3 root 3 feet times 12 feet. 3 times 12 is 36. And we just leave that root 3 tacked on there. So our answer is 36 times root 3 square feet. Okay, let's do one final example. This is a 10-sided shape called a decagon, but the process remains the same. Dot at the center, line all the way down, and let's make our triangle. Let's figure out what our angle is right here. 360 degrees divided by the number of sides. It's going to give us 36 degrees. Half of that is 18 degrees. And then we know since one side length is 9 centimeters, half of that right here, it's going to be 4.5 centimeters. And we're looking for the apothem. So remember, we have an angle. We know the side that's opposite of that angle, and we're looking for the side that's adjacent to that angle. So we're going to use tangent again. Tangent of 18 equals our opposite, 4.5, divided by our adjacent, which is the side we're looking for. I guess I should say the length we're looking for. So if I rearrange this equation, this is 4.5 centimeters divided by tangent of 18. If you plug this into your calculator, you'll get 13.85 centimeters. So my area now, 1/2 times 13.85 centimeters times, remember this is a decagon, a 10-sided shape. Each side is 9 centimeters, so our perimeter is 90 centimeters. Plug this in all the way, you're going to get 623.23 square centimeters. Alright, I hope this video helps you out.